Namaskar. So in this lecture, let's see what is transpose of a matrix and what it means, and also in a later section we'll see that utilizing the transpose of a matrix, what is the meaning of a skew symmetric matrix and a symmetric matrix. So let's see first of all what is transpose of a matrix. So to understand the transpose of matrix, let's have a matrix first. So let's say you have this matrix which is something like this. Right, it is how much the number of row 3 and number of column 2, so it would be a 3 cross 2 matrix. Now the transpose of matrix would be it would be A dash would be called if you change all the rows into columns and columns into rows, right? So it means that if you change the column, so if you can make the reverse of it, so you can make a 2 into 3 order matrix where the number of row is 2 and number of column is 3. So how you can make it? So you can have 3 root 3 0 5 1 minus 1 5 5, right? So this A dash becomes a transpose of matrix A. So in general, if you talk about, if you represent A as we keep doing it like Aij element, and in this bracket where Ij can be any natural number and Aij can be any real number, right? Or of course right now we are discussing real number, but it can later in advanced levels you can have any function or any complex number as well, but right now let's focus on the real number. And let's say then Aij is there and it is a m cross n, then you can have a transpose matrix which you can divide if you have a ji here, and it will become n cross m matrix. It means that the jth row element, ith column element, it will reverse. That means the column number becomes row number and row number becomes column number. So all the elements are according reverse. So for example, let's say if it is A11, this is A12, right? So here it becomes what? It becomes 21. So it becomes A11 is there and A12 becomes A21, right? So this is where your value change, so it becomes AGI. So this is how transpose of a matrix is defined, where you interchange the value elements at the column to the corresponding row value, right? So you change the row values with their column values, and then that will become a transpose of a matrix. So there are very nice properties associated with it. So the properties of transpose matrix, let's see what are they. Property of transpose matrix. So the first property you can have is that the transpose matrix, the transpose of there is a matrix, let's say A, then transpose of transpose would result with the same matrix. So we'll see some example with that, how we can see how it will follow. Now you multiply a scalar with a matrix and take transpose of it, so it will be equal to a scalar constant and the transpose of that matrix for any k which is a constant value. Now the third property is that if you have a addition of the two matrices and you take their transpose, it will be like the transpose of individual matrices. That is another very good important property. And now if you have a product of the two matrices and you take the transpose of there, then it would be that it would be commutated and individual matrices. So it should be that B dash A dash, the transpose of B multiplied by A. So remember that the shifting is the location, right? So it is left multiplied and here right multiplied. B is multiplied towards the left and here to the right. So that is a very unique property. So let's understand with some very brief example. So let's say if we have a matrix which is let's say if it is A is equal to 3 root 3 2 4 2 0, right? And we have another matrix which is 2 minus 1 2 1 2 4. Now let's verify the very first property, which says that a transpose of transpose is equal to the same matrix. So to do it, what we can do? So for that, first let's take what you have 3 root 3 2 4 2 0, right? This is what your A. So if it implies that A dash would be you replace the row with the column, so it will have a 3 rows, so it's root 3 3 2. So this will become in this direction and this will become in this direction, right? So 4 2 0. right? So this is your A dash matrix. Now you again take the transpose of this, so now you again rechange, so it will have a this row will become here and this row will become here, right? So you can have 3 root 3 2 and here you can have 4 2 0, right? Now you see that this is the same matrix which we started, so it is equal to it, so that you can have very easily seen to this. Now talking about the second property where we had right, a plus b dash is equal to a dash plus b dash. Okay, so now let's say first of all let's find out what is a plus b dash. So what would be that? So it would be you add the two matrices, so it is the matrix A and B dash. So if you add, then you will get the corresponding value. So it will have 3 plus 2. Then you would have right. Let me again write the A and B value, just to not forget. 3 4 row 3 2 2 0, and your B is 2 minus 1 2 1 2 4, right? So A plus B will be what? You add these, so 3 plus 2, then you would get root 3 minus 1, and then you would get 2 plus 2, and here you will get 4 plus 1, here you get 2 plus 2, and here you get 0 plus 4, right? So you solve and then you get the value is something like this: 5 root 3 minus 1 4 5 4 4, right? You get a 3 cross 2 matrix, 2 cross 3 matrix, right? Now let's find out what is the value of A dash. So A dash would be your A dash would be what? It can be that will be converted into columns, so it will become this, and 4 2 0. And what would be the B dash? So it will become 2 minus 1 2 1 2 4. Now let's get the value of A dash plus B dash. So what would be this value? So you just add, and then what you will get? 3 plus 2 5, 4 plus 1 5, right? And then you get root 3 minus 1 here, 2 plus 2 4, here you get 4, and here you get 4, right? Now let's take sorry, here it is we had started with A plus B, right? So then this is A plus B, then what would be the here what would be the A plus B dash, right? The transpose. So here the transpose, this would imply it would be 5 root 3 minus 1 4, so it will become 5 root 3 minus 1 4, and here it will become 5 4 4, right? Now you take this matrix, you just compare this here, and you compare this here, right? So you get the both. So it would mean that if you are taking A plus B and that transpose, that is equating to A plus B plus A dash plus B dash plus, so transpose of A plus transpose of B. So this property you can easily see now. The other property, as we had seen, the other property, the third one, which we had said that if A dash is equal to K A dash, right? So let's say first you have some matrix A, for example, let's say you have a matrix A which is, let's say 2 minus 1 2 1 2 4, right? So let's say some constant K you multiply with it, so it means you multiply with each element, so it becomes 2K, it becomes minus K, it becomes 2K, K 2K 4K, right? Now let's have the K dash value, then what you would get? Then it would mean that it would become rows become column, and column become rows, so it becomes 2K minus K 2K K 2K 4K, right? And now you take K out, then it will become 2 1 minus 1 2 2 4, right? And here if you take A dash from here, so what would be there? A dash is equal to, it will be 2 minus 1 2 1 2 4. So now you see this A dash is equal to this value, so you can replace this as K A dash, right? It means K A whole dash is equal to K A dash. So that is another important property as we just saw. Now let's have a simpler proof for the fourth one, which is saying that A B dash is equal to B dash A dash, right? So let's say you have a column matrix something like this, 2 4 5, and let's say B, you have a row matrix which is 1 3 minus 6, right? Now you take product. I'm just taking a very simple value because it is easier to get the product. So it can 2 4 5, and then you multiply 1 3 minus 6, then what you get? You get minus 2 minus 6 12 4 12 minus 24 5 15 minus 30, right? You just multiply with this. So 2 into 1 minus 2, first row first column, right? Second row second column. So that way you keep filling the space. So it is 3 cross 1 and it is 1 cross 3, then you will have a 3 cross 3 matrix as it is filled here, right? Now let's find out what is your AB dash, right? So let's say, so what would be your AB dash? The AB dash matrix would become, again it's a 3 cross 3, but row and columns will be interchanged, so it will become this column, row becomes this column. So 2 minus 6 minus plus 12 here, and here it is 4 12 minus 24 and 5 15 minus 30, right? So this is AB dash. Now let's find out individually what is A dash. So A dash will become your minus 2 4 5, and your B dash will become, from here you see it will become 1 3 minus 6, right? Now let's find out B dash A dash. It will become 1 3 minus 6, and this will become minus 2 4 5. Now you multiply do the matrix multiplication, and we'll get something like this, which will get minus 2 4 5. Here you get minus 6 12 15 12 minus 24 minus 30, right? Which is equal to, you see this is the same value here. So AB dash, right? So it is AB dash. So now you can see that AB dash is equal to B dash A dash. Alright, so this is about the transpose of matrices, and now you simply see that how we can prove that, and this is very important property when we are dealing with the large of matrix multiplication. So these information, these properties are very useful, where you can directly apply and you can simplify the problems in a much faster way. So this is all about transpose of a matrix. Now we'll see some special matrices based on it, this transpose of a matrix, and that would be a skew symmetric matrix, symmetric matrix. So what are those? We will discuss that in our next lecture. So see you there. Thank you.